Cheers. Good morning. My camera's in a new place. So if I'm looking at OBS, I'm not looking at the camera. Sorry. Cheers. Hi. Bought coffee. It's been a while. How's everyone doing? I hope you're all well. Oh, this is going to be weird with the camera here. Sorry. I'm not talking to everyone. Yeah. Hi. Sorry about the last few weeks. It's been busy. Things just haven't lined up. And I've been on site every Wednesday. So I stream in the morning on a Wednesday, and then there's no point in me going on site. By the time I get there, I can't get what I need to get done. So, yeah. We'll see if many people come back to watch the stream. Not that there've been massive numbers anyway, but we'll see if YouTube sends out notifications to everyone. But hi. Hello. My coffee's a bit cold now already. Oh, not quite. It's kind of lukewarm. Got all sorts of interesting things to talk about today. Maybe not so interesting. I don't know. Oh, I left my hot plate on last night. Jeez. Not on as in temperature, just on as in powered. I don't like leaving it powered. I don't trust it. Anyway. No notifications. Bummer. Yay, YouTube. Woohoo! Winning on the YouTube front. And then again. What? I did. Okay. Oh, robot car. Cool. Nice. So speaking of laser engraving, I posted on Discord this morning in the CNC and milling channel. I haven't been. I mean, I use LightBurn for my laser, and I haven't really been following it much. Not as much. Not like I did when I first started using it. And I saw an announcement that on the 24th, so in 6 days, they're releasing their first version of MillMage, which is they've made like a LightBurn, but for CNC. They called it MillMage. They're showing just general CNC stuff. I don't know how well it. I mean, obviously, even a CNC mill is still 3-axis, right? But I don't know how well it's going to work on an actual milling machine like mine, or if it will at all. But anyway, I'm going to let me just. I'll post the video link in here if I can work out how to copy that freaking link. Here we go. Yeah, so I mean, LightBurn's an amazing piece of software. It really is. So this is their release video. It's actually quite funny. They show the whole team. And I started using LightBurn when it was just Oz, who is the founder. It was just him, and he was like buried trying to get all the coding done and all support and everything else. And then he brought on Dave, which is the second guy, and whatever. Now there's a whole team of them, which is pretty cool. But yeah, they've got some interesting software coming out for milling. How's that for a good segue from laser cutting and engraving? Yeah. Anyway, I'm curious to see what it looks like and what it does, but I can't see me moving to anything else anytime soon. I'm just trying to learn what I've got here. Like this was my roommates with their music playing. Oh, awesome. Glad they liked it. I'm not overly happy with the audio reactive stuff, the code that I've written, but whatever. It's my maths, my Fourier transformation maths is just not good enough. It's not quite there. Meaning it's not there at all. Not there at all. Bruce, you're not supposed to be here. Oh, okay. 5 minutes, then you're going. Cool. So hi everyone in the chat. I've missed you all. Byte bashing is driving me bonkers. Yeah. Coding in general, driving me bonkers. So speaking of coding in general, okay. I'll wait a little bit before I go through the list and say hi to everyone because I'll let it fill up a little bit. Haven't even got a whole screen of chat yet. I'm not on my side. So I'll wait a bit, but I want to do an update, give you an update on something that has been driving me nuts, and yeah, it'll turn into quite a long discussion. I think maybe that was LightScribe, wasn't it? LightScribe. I remember LightScribe. That was a touch pen. That was a light pen for the Amiga. LightScribe. Who just mentioned that? Well, I mean, I know Steve just mentioned it, but what brought that up? Oh, you're talking about LightBurn, software that wrote on CDs and then... Oh, LightScribe was... Maybe LightScribe wasn't what I think it was. Yeah, no, this is LightBurn. Burning stuff with light. With your doo-doo-doo laser eyes. Choo-choo-choo. Anyway, Ian, have you been spamming Steve? Oh, I think I'm gonna... Hang on. Can I mute? Probably not. Sorry, I got a bit of hay fever or something going on. If I spontaneously sneeze towards the camera, I apologize. Yeah, LightScribe, I think, yeah, that was writing software. There was so what was that light pen? What was the light pen called for the Amiga? Remember, was that like you could touch points with it and whatever? Light something. I don't know. Anyway, okay. My chat screen is full, so I'm going to say hi to folks now. Deshipu, good morning. Graham, hello. Nom nom nom. Beata, hi. Johnny. Mirror, hello. Feather bender. Just don't bend my featherboards. They're not flexible. Disc Maker, hello. Andy Mouse, Squeak. I can never remember who AJB is. Oh well. Steve, SDG Electronics, hello. Bruce is here and then gone. Ian Scott Johnson, hello. Oh, hi. How is Scotland? Must be beautiful weather this time of year. I'm going to go backwards now because it's jumped. Yeah, I thought the pen was also... I thought it was LightScribe. Anyway. Mad Chicky, hello. David Dessa, hi. God, I gotta look at my screen and get closer. No, I think that's everyone in the list. No, Peter Homan, hello, Peter. Just on top of the CD, I think there was some software from my old Yamaha drive that could run text pictures to the data side. What? You're talking about? I thought you were talking about writing data to a CD, not actually drawing on top of a CD. Really? Okay, so what? AJ is Adama Error 404 Workshop. The M5 stack dude. The what? What are we... Okay, you've lost me. You've completely lost me. Anyway, so Stop screaming at him! Okay. This has been the bane of my life. See this thing? Chuck it in the bin. Chuck it in the bin. No. So apparently, like it's actually called a light pen. I can't remember what it was called. I remember using one. I can't remember what it was called. So, does everyone remember this? Yeah. I've got some pretty cool firmware for it. I've been stuck on it for quite a while though, and there's a fundamental problem with it. This is not what I was going to do. I'm not doing this on my stream today, but there's a fundamental problem with it that I want to talk about, which it's quite difficult to solve. So, I don't know if I want to go into this now, but I'm going to go into this now because I've bought some stuff to try to solve it, or I'm going to try. So my controller board, let me put this down. Okay. So my Omni controller board, which I still haven't released. God, my camera's moved. Everyone, my camera's moved. I've already said it. Focus. Look at that. Oh. So this board, I still haven't released them. I've got people on the wait list. I'm not going to release them until I've got workable software, firmware. And there's a fundamental problem with, well, it's not just this, it's in general. I've got 9 axes of IMU on here. I've got a 6 axes IMU and a magnetometer. And I've written some pretty awesome calibration tools for the magnetometer. It's web-based, so when the firmware on here, you connect. Can I maybe even show it in some form or another? Maybe. Hang on, I'll see if I can even bring it up. I've spent way too much time on this, and it's fundamentally flawed, and I'll tell you why. Well, maybe some people can guess. Let me see if I can even get onto this. I've just plugged it in. I've got no room on my desk. I've been packing bags and assembling stuff, and what is this? What is it even called? What's the IP address going to be? Holy moly. Okay. No, not that. Start local. What have I called it? Okay, I need to go into. Actually, it might come up in serial. Just hold on a moment. Sorry, everyone. There'll just be a moment while I get sidetracked on this. You're going to give me oh, you're going to disappear now, aren't you? Oh, that sucks. Do I get a IP address connecting to Wi-Fi? Give me an IP. Oh, 165. Okay. 165. Yay. Okay, so. Oh, will this even fit on the screen? I don't know. Let me just switch to here. Oh, no. Wrong window. Shh. Oh, bad morning. Let's start again. Okay, so here. Right, so this is my interface. Gotta love the colors. Hope I don't blind everyone. Bigger. So this is my, well, it's part debug interface. This is what I've been working on for this thing. And I've been working on, it's got a FK mode, it's got an IK mode. I did not mean to click on that. You can, like, it's sitting still and you see this drift, the heading. So it's got a calibrated IMU. So I'm just rotating it here, right? It's got a heading. It's using sensor fusion to do the heading, right? Because I need to be able to get reliable heading with this thing. But it's fundamentally flawed. I'll tell you why in a moment. But if I go to I've got a built-in calibration thing, right? So I've got this where you can, when you start the calibration, oh, this is going to go really badly. It's in my hands, right? I'm going to wreck the calibration now, but it's fine. If I click start calibration, it does this whole mapping. Anyone see this? Oh, and I can't even do it with my hands. I'm going to break a cable. Anyway, and the whole idea is I can't even do it because I don't have enough coverage. And it maps out and it shows you which ones are done and which ones aren't. It's really friggin' hard. Oh my God. Can I get to 100% coverage? Okay, I've got to 100% coverage, but I need a few more samples. Okay. It's not great. Why is it not letting me save it? What have I done? I've broken it. Why isn't the save button working? Anyway, so like I've spent a lot of time on this, yeah? I don't know why it's not letting me do it. And I've got like full driving control from here. And this actually, doing this just pumps commands to the thing. I can actually type commands in to make it move. I've got waypoint finding. I've got all sorts of stuff, right? And fundamentally, it's not usable because I'm going to close this. I'll tell you why it's not usable. I'm going to unplug it, put it back on the ground because it's a naughty boy. A naughty boy. So, we'll get to the PCB in a moment. So the reason it's not usable is because to calibrate a magnetometer, you need to, well, ideally, it needs to have no magnetic influence around it. Okay? And when you have magnetic influence around it, it wrecks the values. It influences, right? And gives you alternate values. So the way around that is to calibrate it in its environment that's going to be shipped in, right? So like, for instance, there's a magnetometer inside my watch and they don't calibrate the magnetometer externally. They wait till the watch is assembled and they have a tool that calibrates the magnetometer inside the watch. So therefore, all of the, metal and electromagnetic stuff that's radiated off all the components are all taken as part of the calculation. And so you end up with a calibrated magnetometer for the watch. The problem is, you saw me trying to twist it around. You can't do that on this car. It would have to be fully assembled and then it's got to be calibrated. And it's impossible. And I've broken the, trying to do that by hand, I've broken the battery wires multiple times. I've broken the wires going to the encoders multiple times, and usually you mount the magnetometer on sensor mast. But that still won't help. And it's, for me, for a one-off, I can do whatever I need to do to get this calibrated, but the whole point was to make a board that other people could use and firmware that other people could use that they could mount on any form of robotics, whatever, and be able to calibrate. And that's just can't happen. So I started, the sub for the boot. What? So no 200 watt sub for the boot. Hello, Sean. I don't know what you mean by that. Sub for the boot. A subwoofer? What? Anyway, so the first thing I was doing, I started designing this in CAD, or I started sketching it out first, and then I went to CAD and I realized I couldn't do it, was I was going to build I can't remember what they're called now. You know, the, like those 3-axis ring things that you can, it can, well, they're not 3 axes there. That's the problem. Like a ring, it can turn this way and then it can turn this way, and you can kind of, I can't remember what they're called. Totally gone blank. Anyway, I need one that can do also rotate this way. Oh my God. My camera has decided to go into, go away. Zoom away. A gimbal. Thank you. But I need a translation on 3 unique axes on a gimbal, and that's actually really difficult to do. But I need them motorized. I need all 3 independently motorized and controllable. So my thought was, if I had, I'm just going to take this now. If I had this is the size of my gimbal, and my car would be mounted inside, like this, right? And then the gimbal could do all the rotations it needed, right? On 3 different axes to accurately map out that whole thing. The problem is, who's going to build one of these things? And that's fine if I'm shipping finished cars, but it's not going to work. Anyway, so ultimately I can't use a magnetometer because there's too much influence from the motors and everything else. And so I can't use a camera or cameras. Yeah. When I say I can't, there's lots of ways to solve this, but this needs to be solved by anyone, solvable by anyone that wants to get one of these things and put it on a mechanism car, right? So it can't just be solvable by me. It's got to be solvable by anyone without, hundreds or thousands of dollars worth of equipment. Just can't put it in a washing machine. Yeah, it's a shame I can't. I don't need to tumble it. I need to accurately rotate it. So I can't use cameras to do like vision and mapping, QR codes or whatever those other codes are called or whatever. That doesn't work because not everyone's going to do that. And so I started looking again back at those, the mice sensors. And they're actually, it's the ideal way to solve it with 2 of them, right? Optical flow sensors on the bottom. With 1, you can get XY translation. With 2, you can get XY translation and rotation. And it's not perfectly accurate, but between that and the gyro on a 6-axis IMU using sensor fusion, that's the backup, you can get pretty accurate heading. The problem is, I started looking through all the different options and there's nothing that suits because I can't use one design for a mouse because they're designed that with the lens, they have to be within 2 millimeters, like between 2 and 2.6 millimeters from the surface they're scanning. Well, I can't do that because the surface is down here. And even if I dropped a board low, I can't have the board scraping along the ground when it's driving. And so the other option is the ones that you can get that they use in drones, which would be ideal. But they have a minimum of 80 millimeters. They have to be off the ground. So I can't put the sensors 80 millimeters up looking down because they have an 80 to unlimited range and a mouse has a little tiny window. So a sensor mast doesn't help me. I need to be able to look down at the ground. I can't look down through the car. And I can't have the car or anything moving or changing on the car as part of the influence. Right? So using the sensor flow, that they need to be looking at the ground, looking down, like a drone does. So I can't use the drone ones. Sensor umbrella. Right. Sure. So I'll end up with a $1,000 solution for anyway. So that's why I've been stuck on this chassis, this car, and the fact that the mechanism wheels slip by design, but because they slip, that completely destroys your ability to do. So I can't use encoders as part of the magnetometer fusion to calculate rotation because they slip. Right? If I'm on carpet, they don't. If I'm on a polished floorboards, they slip all over the place. And within seconds, you've completely lost your heading. So I know that there have been people waiting for me to release these boards and whatever. I've really spent a lot of time on the software side on this thing, but it's other than saying drive straight or strafe or rotate on the spot, that's all it can do if I don't need heading. anything else I want to do with it requires an accurate heading, and I just can't do an accurate heading. Hey, Mary Poppin may be interested. Well, it's not been a learning experience. It's been a frustrating experience. Anyway, I'm going to move on from that. I just want to let everyone know that there has been work on that. And every once in a while, I chip away again. And I have ordered some sensors and lenses. They're kind of the mouse type ones. I'm going to see how far away from the ground I can put them and still have them, because the further away, the less focus. The less focus, the less detail that they can pick up. So like on my desk, right, my mouse works fine on my white desk here because it can actually pick up all the little texture on the desk. But as soon as I lift it, a centimeter off the table, it can't detect anything anymore. But if I do that on a very detailed surface, it can still get some movement, but it's blurry, right? So the blurrier it is, the more detail you need. Okay, there you go. Now I need to find where my camera controller software is so I can unzoom this thing. It's doing my head in. Whenever I lift my hand up, thank you, don't move. I need to turn off the gestures. There we go. Now it's not going to do it on me. Yay! Now, if you put my hands in the way, it's not going to change. Can you use a lens to move the focal point to the ground? I don't know. They have lenses they come with, or you buy them with a lens, but I don't know what type of lens I could possibly use. And again, it's got to be a solution that everyone can do. Like, if I end up having to either ship this with a optical sensor solution that is this abnormal thing that has to be mounted in a very particular place on whatever you're making, then it's pointless, right? At that point, I need to actually ship a finished product to someone, not here's a platform that you can use that you can put on anything. So there's just no point at that point. Okay, so okay. So some exciting news. I'm really excited. Okay, whatever. So some of you might remember this board that I was working on a few weeks ago. I've worked on this several times on the stream, but I finished it off a few weeks ago. Well, this is actually in production, meaning this is in a test jig now, and this works, and it's insane. It actually, a bit hard to see like this, mate. Can't remember if I've got models. Do I have models? I do. Don't worry about these right now. I'll talk about that in a moment. So this, oh God, these white looks shocking. I was taking screenshots yesterday and I had to do it against white. Okay, that's a bit better. So this actually worked really, really well. And it's in a proper bit of nails jig. My client's got when they first came out after the Kickstarter, he bought a Carvera, the original Carvera, and it's been sitting in a crate in his office for a year or whatever. We pulled it apart, set it up last week, and we grabbed all the acrylic off these, the Chinese box test jigs you can get with the big clamps, the full fixture thing. And we milled out all of the acrylic on it and set it all up, and it works great. So the firmware I've got is GUI driven, and it actually tests two devices at the same time, simultaneously, including I2C and ESP tool to both of them. It does multiples. It does erasers and flashes test firmware, then erasers and flashes production firmware, and it tests everything. And it does it all in parallel, just using locking, all in Python on a Raspberry Pi, and it works absolutely great. But I did make one mistake, which I'll fix on here. I had, for the DUT1 power, so that enables the 5 volts on or off, so I can control the power on the boards. I had that connected, to the 3.3 volt line. So I had it up here, and that meant it's always on. Yeah, so I did a bodge on the board, which fixed it, and I've fixed it here. But there's one fundamental problem with it. It's my fault because I didn't take measurements first. But I'm using these surface mount connectors, which are fantastic. I love them. These are original Wagos. They're 2.54 millimeter, and you just get DuPont. So the way the fixture works is DuPont cable on one end goes to special receptacles for the pogos that have a like a pin on the bottom that go into a DuPont cable. So it's basically like normally you'd put all the pogos on a PCB, all the receptacles, and you'd feed the pogos in. But these are all wires that go from here to acrylic. They sit in the receptacles sit in the acrylic. Works really well, except the height of the base of the test jig. So the PCB sits on the bottom.
Chat has disconnected.
Thanks. PCB sits on the bottom, right? And then you got wires going up to the acrylic. The height of that base is too short. By the time with these things, by the time you get the pins in, the wires, and then you get the other end into the pogos, it's flexing all the wires sideways. There's not enough height. So I'm going to do a respin. What we did at the moment was we took 2 different jigs. We dismantled the base off one, took the bottom off, and we made the other one double height just for now to solve the problem. And we were just testing panel after panel after panel, and it was awesome. But there's a few things I want to change on the board. I'm going to move to, unfortunately, solderable screw terminals on the side. So the wires will come out at the sides and then up, rather than up and bend down and then bend back up again, right? So I need to get rid of all of these. I need to put screw terminals on, and then I also need to put a place to put a switch. So there's a switch on the case, and right now there's no switch for the power, the main power that goes in. So I want to have the main power come in and then go via the switch, so we can turn it on and off from the outside. Yeah, and I also need to break out 2 of these power pins, or this one here, which is 5 volts, and this one here, which is ground, because they need to go to the screen. And when the ribbon cable's in, I've got no access to those pins. But it works. It worked first time, and apart from that bodge, and phenomenal, really. It takes 40 seconds to test 2 boards concurrently, fully test 2 boards concurrently, and flash production firmware on them, which is, and it does it all in panel. Also have to push type side entry. Do they? But no, sorry, they do, but they're through hole. Well, I've not. The only ones I've seen that are surface mount, they take up way too much space. Like the footprint size on them is huge because to mechanically hold them. And the truth is, I have shit tons of. I mean, that's 3 lots of 4s connected there. But I have so many blue screw terminals here because of my. I don't have one. For once in my life, my Reflow Master Pros, they all use. I got tubs of them. And I just need to make 2 boards, so it's not a big deal. I'll just, solder them on. But I was trying to avoid doing as much through-hole soldering as possible. But anyway. Now, the other things, there's 2 things that would be really cool to add to this. Right now, there are 2 tests that we can't do, that require manual intervention. One of them we're doing, which is just looking at an RGB LED. Hello, Quindor, how you doing? And hello, Technubulus. So there's a down-facing RGB LED that no, that's not true. It's an up-facing because it's a reverse mount. And so we visually, look, I just set it to white, right? And we see two white. So the whole time the board's being tested, they're both sitting there just white, right? If white doesn't work, it means one of the channels in the LED is busted. But it'd be nice to not have to look at it, right? And I could use a light sensor, like one of my ALS things, but there are no ADC pins on a Pi, so I don't have to put ADC hardware on there. The other option, though, I thought it was to use get two color sensor modules, Adafruit modules, SparkFun, whatever, just, I2C modules that sit where the LEDs are over the top of the LEDs that go I2C back to this test board. The problem is I can't find anyone that has, I found some stuff on Amazon. I was just looking. I can't find anyone that makes sensor boards that has the address changeable. So the one from Core Electronics have got one, part of their PicoDev range. They don't break out the address pin. Adafruit's one, don't break out all the ones I can find. They don't break out the address pin. And so I need to have two of them. And I can't have them both on the same address. To do that, I have to put an I2C mux on, which is stupid. I don't want to put an I2C mux on the board. I'm trying to find... I don't even really care how good or how accurate the color sensor is. I want an I2C way of checking that the LEDs work. And ideally, a color way, because I want to not just have a brightness check, because there's a lot of other influence when it comes to luminosity and brightness, but actual color. Because if I have a color sensor, then I can actually check all channels. I can check the reds, check the greens, check the blues, right? But I can't find anything that lets me put two of them in a row and change the address pins, and it's just infuriating. Now, the other thing that I need, which would be really good, and this is something we don't check right now because there's no way to do it, is that the devices that are being tested are always, when they're a product out in the wild, they're always on. They're always powered by the battery, right? And the device is asleep. Okay? It never gets switched off. And the way you wake it up is there's a Hall effect sensor on the front. And you wake it up with a magnet, right? And you shut it down with a magnet. It's this whole ecosystem. It sounds a bit weird, but it's actually a really great system. And so I need a way to check the Hall effect sensors are working. And the only way to do that is to either manually wave a magnet in front of them, which really defeats the whole purpose. Test G can't directly interface to the pins of the LEDs and then read out the voltages. No. Well, I'd have to firstly completely redesign the products to add test points. To the interface pins and read out the voltages. It's a WS. It's a addressable LED. It's how would I do that? Anyway. Yeah, I'd have to redesign the boards to put test points on those to be able to work that out. Anyway, it's not really a no, it's not a dumb analog. It's a so there used to be 9 LEDs on the board, and now there's 1. Thank God. Yeah. So the Hall effect sensor, other than waving a magnet in front of them, the only other way is to use an electromagnet. I've been trying to find a 5-volt. Hey, Art Daniel. I've been trying to find a 5-volt electromagnet. Can't find a 5-volt, or maybe ones that are from China. This says 5-volt, 10 mil, 5-volt. But I need to be able to, because I don't have, I've only got a 5-volt voltage source. And I'm going to have to, for something like this, like ideally I'd want something that was, that I could control on and off that wasn't just feeding power to it or not. But So I prefer SPI over I2C. Hello. You know what? Yeah. Try to find a color sensor with SPI. I'm sure some of the ICs can do it, but I've not found a breakout board that has SPI for a color sensor. 5-volt, 5 kilogram holding force. I mean, these are huge. These other ones that I found are as big. They're half the size of the actual boards that we're testing. Right? I need something small, and so I started looking at if I could convert a magnetic speaker to be a electromagnet. But the amount of hacking on that to do, and it won't be powerful enough probably to register the magnet. So I just want to be able to read the Hall effect sensor when it's on, when there's a magnet there and when there isn't one. So I want to be able to switch it. If we can't do that, we can't do it, right? There's, at the end of the day, there's limits. But take out the coil from a doorbell. Yeah, this has got to be repeatable though, and I need to be able to mount it onto something in the jig. We just need 2 I2. No, it needs to be repeatable. I need 2 I2C modules per test jig, per product that's being tested. No, I need something that's a proper solution. The same with pulling things apart. I need a mountable, I need to be able to mount to the acrylic face something that is manufacturable and reproducible that can interface to the controller board, right? Yeah, I know I can put a mux. I don't want to put a mux. I don't want to add just to be able to use 2 I2 devices. I really don't want to have to use a mux. But anyway, so I have this. So I've got at least this interface stuff changes to make, but I've also got another test jig I need to start working on. I think I mentioned it earlier on. I can't remember. I need to be able to, I'm sure there are fabs that can make a custom coil. Yeah, I need 10 though. Uses frequency out. I don't know what you mean by frequency out. I need to be able to set the address. What do you mean by frequency out? I have no analog. It's got to be, I need to be able to read the value via I2C or SPI. It's got to be via a bus. And I need to be able to, right, yeah, I can't use that. No, it's got to be I2C or SPI. Oh, no, it's got to be I2C. It can't be SPI. It's got to be I2C. An I2C solution. I don't need analog to read the period. It's just a timer. Yeah, it's on a Raspberry Pi. Okay, it's not being read on a micro. It's being read on a Raspberry Pi that has an operating system in the way that makes it very difficult to accurately read. Yeah. Anyway, the other board I need to make is I need to use, I think I've shown these. I've got a whole bunch of these ST-Link minis. Which color sensor has a selectable address? None of them. Well, there are ones that have selectable address, but they're not exposed on any module I can find. And they're surface mount, and the pads are underneath, and I'd have to mangle a board to change it. Hello, Radical Dude. So, for instance, there's which one was I looking at? I was looking at one at Core Electronics. Light color sensor. Oh, gotta switch back. So Core have got this PicoDev one. So the VML, the 640. This one has an address pin, but it's not broken out. I've checked their schematics. Put a magnet on the plunger. You could use a 5-volt solenoid. I can't mount a solenoid. I don't have enough height. it's got to be between the acrylic and the board and the pogos, right? Like I've got 11 millimeters and I can't touch the board. So, yeah, not an option. Like whatever I do has got to be very, very small. Like I've even thought about a magnet that's on like a servo arm, so they get brought in, right? And they get pulled away and brought in and get checked and then get pulled away. I can't mount it. I've got no place to mount the electronics for that. No, Mad Techie, that's not an option because I've got no way to talk to that ESP via the Pi to do that because I'm already saturated the bus and everything else with the devices that are being tested. Right. The solution I'm after is the only solution I have, which is I2C. You know, I can get an I2C light sensor, like a lux sensor, but it's not quite the same, and each one's going to influence each other. And that means I'm going to have to alternate when I'm lighting them up, which means I can't program the boards concurrently. You know, we'll live with the manual work right now if that's what it has to be. But it's got to be a workable, repeatable, mountable, 100% reliable solution that, you know, can be given to a 5-year-old who can literally put a board in, pull a lever, lift the lever when it beeps, and done, right? That's it. Is it so you can I2C to the Pi, can't you? I could invest a heap of time making an I2C slave of an ESP32 that's also an I2C master that has the same, that would then have to, well, no, I can't because I still need 2 unique I2C buses and I can't do 4 I2C buses on an ESP32. So I could only have 1 master and 1 slave. That gives me nothing to connect the I2C stuff to. I need 2, or I need a mux, which is the same problem. Sorry guys, sticking an ESP32 on the board to do this is not the solution. It's the yeah, like I'd make a custom light sensor board of this chip before I'd consider doing that. Right? I could make this board but break out the address pin. Right? And that's what I'll probably do. I'll probably make a single board that has 2 of them on there with the address pin set, 1 in, 1 cable going in, that's all I need. But I was just hoping that I could just buy modules, and it's not even a price thing. I mean, there are a whole bunch of other modules here. Why is this webpage just not letting me go back? How funny. Okay, anyway. I've looked through all the sensors on here. I've looked through sensors on Amazon. I've looked through SparkFun. It's all the same. Hey, Gustus. So, no, it's not a one-off. It's not a one-off. Right now it's a 2 or 3 off, but my client's not interested in a jank job. My client wants a 100% reproducible test jig. So if he says to me, hey, I need you to spin up 2 more test jigs, I don't have to scramble around trying to do a hack job on some stuff. Remember what I did last time? Like this is not a maker project, guys. This is client work. This is for a client. He wants a solution off me, a 100% reproducible solution that doesn't require scrap parts from all over the place. It has one with the address selectable by cutting a trace. Which one? Super Bruce? I did look at the SparkFun ones that were on here, just because I can, whatever the price is, I can order them and get them, you know, by the end of the week. So which SparkFun, do you know which one it is? Hello, Mr. Ta-da. No, the future is to use a Raspberry Pi. I need a computer to control it. Has to be a computer to control it. It's not. This is not a Raspberry Pi problem. This is a. Sure, I can stick a mux on, but a mux, it doesn't really help me, because a mux requires then I have to have both modules connected to 2 different headers coming in rather than chaining them. So share Google. Okay. I think Bruce just sent me a by the raw chip and mount it. It can't be on my board. Well, I can make my own board. Absolutely, I can. I just said that. I can do that. But I was doing that means I'm talking about weeks away of having a solution where I could have just bought 2 of these modules that I've got on the screen right now if the address was settable, and I could have had them by Friday, and I could have had them coded and mounted with 1 cable and some hot glue, right? Or sorry, one cable and 2 screws holding it to the acrylic, and the solution's done and 100% reproducible. So sure, I can make my own solution. It's just crazy that I have to. Where's this? Where did that open? Is this what you? Which one did you do? Copy link. Is that? Okay, I've seen this one. No, I haven't seen this one. Luminance and color sensor breakout. How do you know that you can cut a trace? Oh, right. It says or 38 or 39. So where's the trace? So it's not a jumper. Where does it say? Oh, up top. Oh my God. Up here. Okay. Cool. Okay. So what if cool, I've got them. If I can do it on that. No, this is I want to okay, here. Right. They've got them February 25th. Okay. I will I'm gonna sign in so I can add them. Thanks for finding that. I don't know why I didn't see that when I was looking through the other list. Okay, come on. Can you let me log in, please? Okay, 2. They've only got 1 in stock. And they can't get it till March. Bloody hell. Okay, I'm just going to add 2 to my cart. Okay. That's in Facebook address. Yeah. Yep. Group mind work. Okay, so that could possibly solve that. The electromagnet, I just need to buy a couple of small ones, but I need to have switching 5 volts, which means then I'm adding FETs and stuff to here. Google AI sent you there. Really? Okay. Right, back to this one. So, also UART, 6-channel visible light sensor. Okay, I can't do UART. Well, I have to do software UART. So, yeah, it's got to be I2C. I need I2C. Anyway, so ST-Link V3 Mini. So this is for flashing STM32 boards. So I have panels of 10 boards. This is an. Is there anything on here? No. So I've panels. This is a board. This is one of the products, or that's a board for a product. So there's no real place to hold it. You can see there, and on the back, there are, down the side, no, I just put my fingers on it. There's pogos. You see those pogos? Not the center, on the side. Okay, they're SWD programming pogos. Perhaps digital isolation. I need to be able to switch it though. I mean, either way, I need to switch 5 volts to these things. I don't know how much current they draw, and I can't affect the 5 volt source going to the devices while they're running. Anyway, I need to get a couple of the smallest ones I can get and play with them and see what see what current they need. I need to see what side effects there are when I'm switching them. Yeah. So I'm moving on to this one. So there are 10 of these on a panel. I need to be able to flash all 10. They don't have to be flashed simultaneously, as in 10 in parallel, but they need to be all flashed without any mechanical changing during the process. So I can't plug 10 of these into a Raspberry Pi. Even if I got a powered 10-port USB hub, trying to manage 10 of these is going to be impossible. And again, I need it reproducible. So, I need to be able to produce 2 to 5 gigs. So I can't have 50 of these things. 50 of these things on 5 gigs. So my plan is to just put the clock and data pins through a high-speed mux, right? So then I can do multiple. So you can't buy a high-speed mux. Well, you can buy lots of high-speed muxes designed specifically for things like HDMI or MIPI or whatever else. But I'm not trying to switch whole banks. I need to get 2 pins that can go to either this, like 5 things. You can't get 10. You can't get 5. You can get 4. You can get 6. I have 10. I might be able to go to 12 on a panel. That's fine. So anyway, I've been trying to work out a solution. And honestly, the easiest solution I've come up with is to use the mux that I use, the IO mux I use on my SQUiXL, which is a 4-pin mux that can be switched to these 4 pins or these 4 pins. So it's a 4-channel, 4-pin mux. So I've got stacks of them here, right? They're small. They're easy to work with. I've got all the code I need for them. And so my plan is I'm just going to cascade them out to allow me to switch to use 3 of these will allow me to do 12 boards. And so I do all of them, like I switch the top layer's position, and then I do the next lot, so it'll do 4, then I'll switch them and it'll do 4, and then I switch the bottom layer and switch top layer back and it does 4, and then I can switch the other one and it does 4, so that's 16 you can do. Something like that, right? So it probably doesn't make sense, but because I can't find a mux solution that isn't either $37. My thing just did that again. Sorry. I still haven't found that key combination. There's some key combination that if OBS has got focus, it does that. You can cascade because you have access to CS, unlike... What? This has nothing to do with SPI. This is not an SPI thing. There's no SPI or I2C or anything with these IO muxes. There's just an enable pin and a switch pin. So we go on a new project. So I mentioned in my description on the stream today that this stuff's going to be no, but they're always enabled. I'm not going to use. They're just going to be pulled high. I'm not turning them off and on. And the enable pin isn't CS in this case. It's not, because I'm not adjusting what I'm talking to. CS is it's a select pin to say, this is the one I'm talking to, this is not. The enable pin is power it down or power it up. 2 different things. You'll see. Where am I putting this? Sheet. in here, new folder. So just go with this. I'm starting a new KiCad project. One and okay, well, can't do much about the name now. Whatever. Let me put that there. And Gravity Digital 8 channel SQUiXL. What's that for? I'm not. This is what I'm talking about now. Is nothing to do with the previous project. It's the nothing to do with the light sensor. This is a completely different thing. Nothing to do with SQUiXL. So I don't know if you're posting that about the previous discussion. I've already moved on from that. Okay, so I need to get my SQUiXL project. Okay, it's my SQUiXL schematic. So this IO mux here, you could do it with 5 lines of HDL. Well, I can't really do it with 5 lines with this anyway. Whatever. Right, but I already said I don't want to use an I2C mux. I'm not after a mux. I don't want to put a mux on the board. I don't want to have to control an I2C mux. I just want 2 things on 1 bus on the I2C bus. So, and I can solve it. I can solve that myself on my own PCB, or I can solve it with pre-bought modules. Now, if I can change the address line, no I2C mux on the board. I don't have any I/O left on the Pi to control a mux on that. This is an SWD programmer. It's a like a JTAG programmer. So it's a clock and data. And so this I/O mux here is a high speed I/O mux. Like I run SPI through this to whatever, right? So this is what I use on SQUiXL. So that's a mux select. So it's frustrating that in and out is this direction, but whatever. So the plan is, I'm going to move this on this side. No, low speed IC is not going to cut it. No, it's got to be high speed. So what I'll have would be ST1 SWD and this other way. G. That'll be ST1. What's the clock? I can't remember what they call the clock pin. Gee, what do they call the clock pin? Clock. There's a name for it. I can't remember, right? So we've got data and clock, and then we'd have two. I said 2. Push the 3 key. No tech. He has no pins left. What he does, he just needs it to do more stuff. What? I don't have pins left to control a mux on the board, on the other board, and I don't want to put a mux on it. This is something different. So this would be two unique ST links coming in, right? So I don't need. So there's only 4 pins I need: clock, data, ground, and power. Yeah. We don't use the reset line. And so. Pretty sure we don't use the reset line. you're not going to get banned, but you're not being helpful. Pi doesn't suck. It's perfect for this stuff, and it's anyway. And so then from here, I will need. I would have. This would be ST1 out 1. ST1 clock out 1. ST2 out. And then keep hitting the wrong key. Okay, so these two suddenly give me the option to program 4 boards, right? So if I was just doing 8, I could just duplicate this. So make this I don't know, I did 01 then when I did 1 on the other ones, but I'll fix that later, okay? But I don't want to do, I need to be able to do at least 10, but 12 would be better. So I could use 3 of these, but I don't have 6 USB ports. I've only got 4 USB ports on a Pi that I can use in this case without using a hub, either putting my own hub chip on here or using external hub, which is just not a neat way of doing this thing, because they also need external power for it. Well, I'll probably need external. I'll run the external power here anyway. So what I was thinking was, if this 2 gives me 4, then those 4 would give me, I don't know. I can't, it's too early in the morning for the maths. I'm going to just move these away just for now. Okay, you were fixated on your CS stuff, and it's not correct. It's when EN is pulled high, so it's not enabled, none of these do anything. Okay? Select selects as which bank. So this is on or off. That's not select. I don't need on and off. This is not, you can call it whatever you want to do. It's not CS. I don't care. So, whoops. I'm just going to say, yes, it's CS. Let's move on. Okay, so then what does, how am I going to do the maths on this? How am I going to, I should have done this in a table. So if that gives me 4, those 2 give me 4. They give me 1, 2, 1. Can someone help me? My brain, I need more coffee. Cold. So 2 propagates to 4. And those 4 propagates to 4. So that's... Is that 16? It's not about the... I am going to use the select. 2 of those only gives me 8. I need 10. I just said that. I said 2 of these gives me 8. Doesn't help me. Nothing to do with the select or the EN. Okay? That would be 4 devices in, gives me 8 devices out. I need 10 or 12. So if that's 2 of them is giving me 4, those 4 give me 4. So is that giving me 8 here? So is that giving me 16? Or is it not? No, it's not, because I need those, all 4 of those to go into 2 of those, wouldn't I? No. So I made all this up in my head last night this morning at 1 o'clock in the morning, lying in bed. So that's how well this is thought out. Okay, I think I need a table. I think I need to write this out. Except this is not the right... Okay, hang on. No. Let's do this. Okay. Whoa, new. Oh my God, how many spreadsheets just opened? Holy moly. Okay, let's go to numbers. I've lost my page. Okay. No, how many of them are open? So we have... How am I going to map this out? ST-Link 1, ST2, am I going to do it horizontal or vertical? I don't think anyone's watching anymore. It says 35 people, concurrent viewers, but there's only Jay telling me about CS pins. And no one else. I think I've lost everyone. Someone help me work out. Trying to be silent. So when this is enabled, I have these 2 coming out, and they go to here. So this is just replicating. No, I've got 4 there. No, I've got 1, 2, 3. I've got 2 there and 2 there. I've got 4 here when it's on this one, and 4 here when it's on this one. So, no. And I do not get Newton bipolar stuff. What? So you got Mux 1, which has got Mux 1, which has got A and B. I don't know how to map this out. Can you use the opt? Jamal, are you back at the old conversation? If you're talking about a light sensor, I've already found one that I can use. When this is, there's two out there. Gives me 1, 2 here and 2 here. Okay, let me do this a different way. No. Okay, that gives me 2. That gives me 2. That gives me 2, and that gives me 2. Yeah, we've already solved the light sensor though. I've already got one in my shopping cart. Well, I can get more, but I have to get them through Core. But I can look at the opt 404 as well. Thanks for bringing that up. But yeah, I already have a solution for the light sensor, I hope. But that's 8. So that's 8 off 2. So that's 2 devices come in, gives me 8. So 2 of these will give me 16. I could do 12. I can't get 16 boards on a panel. I don't want to get 16 boards on a panel. So I could do that, and then that gives me, that one there, another one gives me 12. So these 4 ICs give me 12, and I can do, that's 12 with 4 of these, which I can plug directly to the Pi, although I'll have to inject power to the devices directly. That's fine. So 4 chips and 4 caps and 4 surface mount connectors going to those, plus power. And I need to be able to 1, 2, 3, 4. I need 4 I/O to control them. It's a pity I 1, 2. This is 4. This one is 4. Why can't I change it? So that's 4, 4, and 4. One more doesn't give 12 because it subtracts 2. You need 2 more. What? Why do I need 2 more? I've got 2 coming in here. Those 2 can be 2 here or 2 here. So that's 4. Oh, where's my traces? Why does it not give me? No, this 16 will be if I duplicated 2 of these. Okay, this is 2 devices, 2 different ST links. All right, so this will be number 3. Where's my? Oh, it's over here. Sorry, the thing, I couldn't see it. So this will be number 3. Oh my gosh. 3, and this will be number 4. The two coming in have to be connected to the outputs of the previous. Huh? No. So this one here, if I just did 2 of these, I'd have 8. Right? But that's 4 ST links, and each one can do 2 because of the switching. So that'll give me 8. But I have 10 on a board, and I don't want to go less than 10 on a board. I can do 12 on a board. That's fine. So this gives me 4. Switching these 2 means I can do 4 boards. Switching these 2 means I can do 4 boards. But if they get put into here, each one of those 4 boards becomes 4. So I get 8. I get 4 here. Like these are just passed through, right? I get 4 here and 4 here. So that's 8 there. 4 there is 12. And 12 out of 4 things. Right. So I thought I could do it just from starting of 2. But I can't because this doesn't do it. All this does is cascade. This doesn't split. Like if this was an 8 channel, then I could put all of this into here and all of this into here. But I can't. Why do you keep pointing the TCA out to me? It's nothing to do with what I'm doing here. What I'm doing here is nothing to do with I2C. And that chip is an I2C/SM bus switch. I know that chip very well because I use them in products here. I've got a whole reel of them sitting downstairs, but it's not the chip I want. It's not what I want to be using. But you brought it up multiple times. I'm kind of unsure why. I mean, technically that would let me go 2 in and 8 out. But I don't know if it'll do. I don't even know how fast this ST-Link. Okay, I need to know how fast the ST-Link transfers at. That's what I need to know before I can. Hello, where's my window gone? Okay. TCA 9.5. It's probably already here. Look, I don't know if I can. No, that's not what I want to say. I want to say, what speed does the ST-Link Mini, is it? V3 Mini E require for programming? No, not require. What speed? Link. What clock speed? Use for programming. Right, 24 megahertz. So I need a 24 megahertz chip, and I'm pretty sure I2C and SM bus does not run at 24 megahertz. That's the problem. So as I said before, I spent like 3 hours yesterday looking at all different IOMux chips, and you can get dedicated chips. Like once you start going to, okay, you can get lots of 8 in that go 8 here or 8 here, right? Or you can get lots of 10 that map out to 2 lots of 10 or whatever, right? Things for MIPI, HDMI, all sorts of things like that. What you can't get is 2 pins in to 10 lots of 2 pins out. Okay, so 2 to 20, right? you can't get those, or 2 to 16, whatever, unless it's for a dedicated peripheral like I2C, or you can get them for UART, but they're still not fast enough, right? So the problem with this chip here is it's a I2C multiplexer, and I use them as an I2C multiplexer on boards for this client, right? But it's specifically designed for I2C and SM bus, and I'm pretty sure the speeds will not go anywhere near 0 to 400 kilohertz clock frequency. Okay, I can't do 400 kilohertz. I need 24 megahertz. So I need a chip that can switch 24 megahertz. Now, these muxes that I'm using here, I know they can because I switch 40 megahertz SPI on them. No problems, right? So could I get chips that might be able to go to 6 instead of 4? Possibly, but I don't have them. I'd have to buy them. I'd have to, you know what I mean? Like, I've already got these in stock and I've used them before, so I'm familiar with them. So, which is the only reason I'm considering using these and cascading them, because it's a no-brainer in terms of, I know it'll work speed-wise, and I just have to spin up a PCB and I've got all the parts I need here. I've even got like this whole packet of connectors, which are custom stupid bloody connectors they use. They use a 14-pin connector and only use, for full programming, they only use 6 of the pins. And I only need 4 pins, including power and ground. And so I had to source these stupid 14-pin. Anyway, I've got them. I've got a whole lot of them. So the idea would be I'd have Pi to USB, this to this header that plugs into the board. I only use power. I only use ground, clock, and data from here that go up to the muxes, and have power come in separately. So I'll probably I'll put a couple of LDOs on with, going to different buses coming from the 5-volt source, and then an external 5-volt source, and then they will all go to screw terminals that go wires out to pogos. Yeah, that's the plan. And it's not, and then plus I'll need a way of switching them. So, again, header to a Raspberry Pi, and it's got to go through a Raspberry Pi because it's a Raspberry Pi that's using OpenOCD to flash the chips via the thing. And I don't even need to know or care which board which of these is enumerated touching which board. It doesn't matter, because I just flash anything that this sees, right? And then I do a mux switch and flash everything it sees, and then I do one final mux switch, and I have to do 1, 2, 3, 4. That's 1, 2, 3. Yeah. 4 mux switches for these, and this one here will just be the first lot. So prevent this one from switching twice. Anyway, if I could find a 4 to 6, 1, 2, no, or this 4, if I could switch this 3-way, if I could get 2 more on here, so if this had 4 in, yeah, can't go 4 in, 4 out. That won't help. If I had an 8, if I could get an 8 in, which gave me 2 lots of 8 out, and 8, 8. I don't think I didn't see one yesterday. 5-volt 2-1 DT 4-channel on switch with powered off protection. Right, so if I could get a 2-to-1 SPDT that was an 8-channel, that'd be great. Then I could do them all through just 3 chips. That's what this chip is. Yes, this is a 4-channel SPDT chip. Low power, high speed. USB mux won't go fast enough. It'll have to be a USB 3 mux. Now, I was looking at the max chips. I don't believe they can go high enough. USB 2.
Cian, chat has disconnected.
Yep. Okay, so this can do full speed. It can do high speed. Right. The other ones I was looking at would only do full speed. Um, One, 2, 3, 4, 5, 6, 7, 8. The problem is one of them's still not enough. I'd still need to use 2. And that would give me 16. And again, it's a chip that it's well, $9 chip, US. And what else does it need, actually? Where was the shit? I've got a typical application. I'd need, would I need to put inline series resistors on them? Wonder if it oscillates. It doesn't say what else it needs, but I'm assuming it's going to need some pretty meaty power. Really? Power and caps? Find that hard to believe if it can go that fast. That's all it's showing. Okay, anyway, it's if you can find me a 10-to-1 or a 12 or a 16-to-1, I could just use one chip, but pretty cool chip. I'll have to bank that in the knowledge base for another time, but as a proof of concept, this is easy to do. Okay, let me just screen every time. Well, there aren't tons of 16 channel, 2 to 16. or one, yeah, it's, when you say tons, don't do a broad search. You need to dig into it. I'm lucky I've got stacks of them, but I want the category. So it's not a multiplexer I want. It's an analog switch that I want, but can never understand what all these numbers are stupid. So 8-to-1, 2-channel. Is that what I want? 8-to-1, 2-channel. Hello, webpage, update. That's I2C. See, I2C. As soon as you go 2-channel, they think it must be an I2C chip. Unless they're talking about the interface. Impossible to know. So what is this? I want to switch I want to switch a minimal number of JT-Link V3 minis to be able to flash a panel of 10 or 12 boards, STM32s. Yeah, so this isn't what I want. This is just mapping A's to B's. I can never understand what they're... Anyway, I have a viable solution in this. Yeah, I'm not looking at 1 port to 16. I want to do... If you think about an I2C mux, I want 2 pins, data and clock, that I can switch between 10 or 12 lots of 2 pins. So on 2 pins goes to this 2, or 2 goes to this 2, or those, like this. But not as, it's got to be able to do 24 megahertz. So it can't be an I2C mux, or, or SMB. It's got to be a high speed switching, like analog switching mux, which is what these chips are, but they're just, I have to cascade them because there are 4 in and 2 lots of 4 out. So that's two programmers in, gives me the ability to write to 4 out. So it doubles my capacity. So this doubles my capacity, and then that doubles it again and doubles it again. That gives me 4, and that gives me 8 and 8. So is that not... No, it's not doubles it again. Yeah, so that doubles this, and that doubles... This one doubles this here, and that one doubles that. So the same programmers gives me 8, and then this doubles that. Yep. I mean, if I could technically, with 2 more of these, I could put 16 on the board, right? 16 on a panel. I could fit them. Anyway, so this is a solution. So then, that's another test jig. And then I've got another test jig I need to build. Well, this one's going to be And this test jig has to test 12, 13, 14 5-volt power sources, 3 3.3 volt power sources, 1 VBAT power source, and 1 main 20 volt power source. And then once all the power rails are confirmed, has to be able to flash an MSP 430. Yay. So I'm going to be using so MSP 430, for those of you that don't know, is a super old, super duper old pre-ARM MCU that is still made today and used today a lot. They're actually pretty good chips, I got to say. So this is the cheapest option to be able to flash one in high speed. Is one of these. So my camera's moved and I keep forgetting where the camera is. So it's one of these Explorer board, and so you take off these jumpers. So that's an MSP. That's an MSP 430 here. Right, that's a programming interface, kind of like what the discovery boards do for STM32 stuff. And the jumpers here bridge this to this. You remove those jumpers and you put your own wires out to your own MSP 430. And so I have to program the MSP 430 in 2-wire mode, which is not fast normally. It's basically bit banging it, right? So right now we're using an Olimex JTAG 2 adapter thing, which is very slow. It takes about 4.5 minutes to flash the MSP 430, and it's only a 36K binary. It takes 4.5 minutes. So with this thing, I can flash the same binary in about 55 seconds. And we've got a bunch of these, and it's got to be automated be able to do it through Python, right? So we just need one per test jig, but we can't flash the MSP 430 until we've verified all the power rails. So my original plan was to use a whole bunch of the INA 260s like I did on the other test jig, right? To test the power, So let me just jump back a bit. Many channels. No, and RF switches will generally they have one in and however many out. Wrong type of switch. So let me just go back to save that. Let me go back to here. Open recent. So this here, there's two INAs I put on here, right? INA 260, and what these do, these are SQUiXL, and what they do is when I'm testing the boards on this device, so they get powered up with 5 volts. I check the 5 volt rail, I check the 3.3 volt rails on both boards via the pogos, right? And then I enable the battery because they're disabled. I go through a load switch here. So that's a 5 volt load switch here, so that all the power starts off. This is the battery. So the power gets turned on, right? And through here, I can check, yes, I'm getting 5 volts to the load, and I can check how much current it's drawing, right? So I can there's no short. And this load switch here has got short protection anyway. It'll shut down if there's a short somewhere. And then what I do is, once I've determined 3.3 volts is running, I then turn on the battery. So the battery's connected here. I turn on the battery and I turn off the 5 volts, right? And I make sure that I can still detect 3.3 volts. That means the battery is connected correctly to the device, right? And if I can still check 3.3, it's still running, right, 3.3 volts, I then report back from the device, because it's running custom firmware, like testing firmware. It tells me what its VBAT reading is through its own voltage divider, which I check, right? And at that point, it should be, in this case, the battery's not, no, actually, no, I don't do that yet. I then turn the 5 volts back on. So the 5 volts is on, the battery is on, which means this now shows me what the charge current is of the battery, right? And the batteries, so the devices being tested are using a TI battery management chip that it can charge the batteries at 850 milliamp. They're very large batteries, so they've got a fast battery charge. So this tells me the charge rate, right? And then I then ask the device what the battery voltage is. And at this point, the battery voltage will be 4.2 volts because the battery's being charged, right? There's no point checking the battery voltage when 5 volts isn't present, because then it'll tell me the voltage of the battery. The battery could be, there's not a lot of time that the battery stays on and charging in the test jig, so the battery's going to drain. So I need to know an accurate battery voltage. If it doesn't see 4.2 volts, it means the charge circuit's not working. So anyway, I was going to use these INA 260s. The problem is they need to be in line with the power rail. So I can't check the voltage and current on a 5 volt pin in a pogo unless there's a load on the other end. So in this case, the load that this is coming through is the battery, right? Battery's being charged, which is what's pulling the power through the 5 volts, through the test device and back again. But there is no load on these pins. There's a load on the board, but this chip has to be in series with the load. So there's power in. Let me go to here. So on the INA, right, there's these power in and the power out. In and out. And there needs to be a load on the out. And that's how it reads it coming through. I have no load. And if I put a load on it, it's actually not testing. Anyway, so it's crazy to put 13 INA 260s on the board to test 13 unique 5 volt sources. And each one has to be tested because each one is its own buck, its own 20 volt to 5 volt buck, 13 of them. And each one can be switched on and off. So I need to test each one. So the only real way to do that is to test with an I/O, right? Through a divider, well, I don't have a 5 volt tolerant signal level MCU or Pi, whatever. So I need to be able to, through a divider, just check that 5 volt is present or not, right? If there's an issue with the buck or whatever, there'll be no 5 volts, there'll be 0 volts. And so that'll give me a low. So an analog switch with one. No, I can't use a current monitor at all, is what I'm saying, because there's no load coming through. So basically, what I'll need to do, this is not the board I'm talking about. So to check the 3.3 volt rails are working, I just need to check that they're working, not how much current they're pulling. So to check they're working, that's fine. I just connect them to an I/O and see the high or low. And for the 5 volt ones, I'll just need 13 I/O, each one with their own divider. I'm not going to do a mux. Again, it doesn't make any sense to go through a mux. And yeah, so that's fine. But each one of those, wish I could show you. I can't show you. So, quick sidestep. None of these products are released yet. Like, we're building stock right now. I don't know at what stage they'll be out, whatever, right? But I'm hoping that once they're out, once it's launched, fully launched, I'll be able to share more about what they are and show stuff. But right now I can't. And I'm sure that's frustrating for you guys because you don't know what I'm talking about. And it's frustrating for me because I'd love to show you what you know, like the board is this big. It's 25 by 25. So 250 by 250 millimeters. It's the biggest board I've ever made. And it's each one of those 5-volt bucks, is connected to a USB. It's basically 12 USB ports on this board going through 2 USB hub chips that connect to a Raspberry Pi. So a Raspberry Pi is seeing 12 USB ports. And they're broken out into headers. And each one of those ports, the power can be controlled. And there's also SQUiXL going to each one of those, when I say a port, like a pin header. So there's obviously D plus D minus, but there's also SQUiXL going to that same header. So every device that gets plugged into that thing has multiple protocols that it can talk, right? So right now, so it's funny, the test jig for the power checking it's one of those things. I can test a board. So on my testing area to the side there, like I've got my power, what are they called? My God, what are they? Power source, whatever. Power supplies. Oh my God. I've got my bench power supplies, different bench power supplies there, right? And I can go through and check all of those power things on a board in about 15 seconds. I can check the whole board. But the whole point of the test jig is for me not to be there and for me not to have a single board and in front of a power supply. It's to put a board in a test jig, pull a lever, and anyone can pull a lever. Anyone can put a board in, anyone can pull a lever, and at the end of it, it's a pass or fail. And if it's a pass, it's all tested and the MSP 430 is flashed. So it's a low volume board that is going to require, I'm trying to make a very uncomplex testing solution, right? The INA chips are not cheap. To put 13 down just to check power sources is just crazy overkill. So I'm trying to come up with a solution that is, cost effective to make for, so if one of these things has 12 ports, then it makes sense to extrapolate that when one of these things is sold, it's sold with 12 other things that go with it. So for every low volume item of this, there's a high volume set of these, right? And then each one of these have accompanying these things. So that's 12 here, and then there could be another 12, and there could be, you know what I mean? But this main board is there's only one for every X of these. So I need to keep this as sane as possible from a testing point of view. And I think dividers is probably just the best way to do it. And that will at least tell me if one of them doesn't power up, I'll know which one and I can look. And unfortunately, all of the bucks that are on there are using that. They've got those new crazy, stupid footprints. What have I just made recently that I can show you? Right. Actually, I've got one. What was it called? Bear with me a second. I'm going to load in a part. Right, this. So it's got these type of footprints. RDNA, blah, 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 whatever. They are a nightmare for reflow. Because these massive pads just, they wick all the heat And generally this will be one of these. One of them is connected to no copper or just a copper plane with nothing. And one of them is usually, in this case, this is the out. So if you imagine you got, and so no, on the other boards I'm doing, one of them is, it's an out. And then normally like that one and maybe in that are ground. Anyway, it really messes with, and these are tiny. So this pad here is 0.25 millimeters wide. I mean, it looks big on the screen. These are really, they're tiny chips, and they just don't reflow well. They're a nightmare. So I'll often, there might be one, not on every board, but if I do a run of like 20 of these boards, then probably 10 of them will have at least one of these that didn't reflow properly. And they're easy to fix. They're impossible to see at the point, like just by inspection. But, they need to be tested. And I don't understand why. There's so much copper on these boards. Anyway. Nice thermal stuff. How much power do they deliver with this? Looks quite beefy. So these do 2 amps. Oh, this one doesn't. This one here is this is a same type of package, but a different chip. This is a 36 volt, up to 36 volt in, 3.3 volts out at 600 milliamps. But the ones that I'm using, actually, are the ones I'm talking about are, let me see if I can find it. Yeah, that one, which is even worse. This one. Okay, so this is up to 24 volts in. This is the one, right? 24 volts in, 5 volts out, 2 amps it can deliver. And it's just a reflow nightmare. So it's normally that, or that. One of those here don't reflow properly because they just, the heat just gets sucked from everything around it. Right? And so there'll be a massive copper thing, like, I can't remember which side, right? And it doesn't really matter what it is, but there'll be something like this. Massive bit of copper going to that, like that, right? There's got stacks of wires and whatever else that's going to, 4 solid layers of copper. So when you've got 13 of these on the board, anyway, I don't really have a choice. There's nothing on the market from so the thing with these is they're fully integrated solutions. So the inductors inside, they're, wow, let me just bring one. Let me, okay, I need to close that because that's really annoying me now. Delete. Let me go back. Web. Okay, so monolith power supplies. Okay, so that's the part number. Here you go. You can all check it out if you want. That's the part number. Hey, Dave. And so, yes, please verify my browser. So 4.5 to 24 volts in, 2 amp continuous, and they don't need anything. So you've literally just got a cap and resistor on the way in, cap on the way out, and a resistor divider for setting the output voltage because they're not fixed. And that's it. No inductor or anything else needed. So the advantage of something like this, especially when you've got so many of them, is that I don't want a part that requires an external inductor. So a part that requires an external inductor means you don't, like, the layout of the board is determines how bad or good or whatever your oscillation through the power rails are and whatever, like, becomes a nightmare. So to use a fully encapsulated package means that whole issue goes away, right? Unless you've not followed the guidelines when you're implementing it. So like they've got a this SW pin, right, needs to go out to, in this case, they don't mark it, but there needs to be an RC filter on that. If price isn't the main factor, those integrated ones will. Yeah, well, in this case, it's not just about price. It's about 13 of these on a board, if they're not integrated, would be, how would you ever rectify the oscillation through the board, right? And we've got high-speed USB and SQUiXL and SPI going out to every port of these 12 hubs, and we just can't have power rippling through the whole thing. We plan to get the storage sort back in stock. I can't get those. The eMMC I was using, I can't get. I had an order in for them, for 100 of them, and it was taking weeks turned into months, and they kept stuffing me around. And so I never really found a comparable eMMC that wasn't triple the price. And I can't really justify selling a storage shield for $55 or $60 US because of the state of eMMC at the moment. So I would like to. I was just looking at it, sitting right here. This is a prototype with a different eMMC. I found some SanDisk eMMC that was only 1.5 times the price, but it wasn't as fast. So I was using Kingston, and they completely just removed the whole range of chips that I was using, and they came out with new ones that are identical specs and 3 times the price. I see what you mean by pin-out positioning, huge ground right beside small pins. Yeah, it's a nightmare. And unfortunately, the board itself, so the current version, I didn't design the original board. I've redesigned a lot of it through multiple steps. Like the one that went in production and the one that's currently being used it's a redesign, but ultimately the thing is just full of copper. It's so there was just so much wicking the heat that is incredible. And there's 2 versions of it. There's the 12-port one and there's a 4-port one. And so I need this testing thing to be able to do either board, right? I can't do 2 testers. So on the 4-port version, it'll just be testing 6 5-volt sources and 3 3.3 volt sources. Anyway, yeah, so this is a really good chip. So anyway, that was the vertical dude. That was the answer. I literally had an order sitting at God, what are they called? At Jesus, what was the company called? Hang on. Never remember. And I eventually had to tell them to go jump. At Avnet. So Kingston forced me to go through Avnet, and Avnet just wouldn't let me buy it with a credit card off their website or with a purchase order. They had to go through. They had to set me up as someone and a blah 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 and constant paperwork back and forwards, and I had to sign this thing, I had to sign that thing, and just every time I sent it back, a week would go past, and they'd say, "We also need you to sign all this paperwork. We need you to fill all this in." And I kept saying to them, "What are you doing? I just want to place one order for a set of parts." And in the end, I just literally said to them, "It's become way too hard." I actually wrote here, "This has become way too hard. Too many forms, too many steps, and we're not finished yet. I'll find an alternative part from a different supplier, so I don't have to jump through so many hoops." And they came back going, "It's an internal process we have to comply with." I'm going, "Yeah, that's just rubbish." Like, really? So that email was November the 5th, and the whole thing started. The first email to them about it all, September, July, 16th of July. So the first time I spoke to Avnet was 16th of July. No. Sorry, hang on. 17th of July. 17th of July. And by November, I when they sent me a whole new set of forms, I said, I can't do this anymore. So, yeah. And as you know now, with the memory shortage everywhere, EMC prices, flash price, everything is just it's skyrocketing. So yeah. Price will start. It's from quite. I don't know about years, but it's going to take a while. This it's just insane what's happening. And the knock-on effects is pretty bad. I mean, there was a while that flash wasn't being touched. eMMC wasn't being touched. I mean, my flash chips that I use on my boards, I've got one reel of 2,000 left, plus a few hundred on my machine, and a reel now to buy is 2.5 times the price. And I can't absorb that. And, adding dollars per board for every board that has flash on it because of it is just, no one's going to buy them. So anyway, there was COVID, there was the silicon shortage, now there's a RAM shortage. That I bought a bunch of Sky High MC chips at ATP ones. Oh, and right. What, you'd pay dollars more per board? Or it'd be more than dollars. I have to increase dollars at wholesale, which means... Anyway. Yeah. Yeah. And it's not just flash. PSRAM's gone up and become harder to get. Oh, so much funds. Prices, well, for stuff like this, prices generally come back down a bit. It depends on the part, but yeah. How's it with... I've got a stack of Giga device flash chips here. I don't use... They're generally more expensive than the Winborn stuff I use anyway. But just everything, price has gone up heaps. Problem for another day. Yeah, I'm just going to keep making until I can't make. Yeah. I can't remember what I was just talking about other than that. Anyway, the power boards and the chips. So, yep. So my plan was to put these in today, but I've done a lot of talking. It's been over 2 hours and I've not done any PCB design changes. Actually need this to be a I don't want 12, I want 8. So the problem with these, I'll show you. Okay. So I have in my hand screw terminals. God, my camera. It's not there anymore. It's here. So you've all seen these, right? These are especially 5.08. I don't know if they're 5 or 5.08. It's impossible to tell. These are 5 millimeter pitch. So you've all seen, they slide together, right? Like that. And you go, yay. And you can slide more. So I need 16 outputs for each device being tested. So that would be 4 lots of 4. So that's how you make, so there it is, 4 lots of 4. Now the problem is, can you all see this? It's bowed. So the way they join together, they naturally bow. And then when you try to straighten them, when you're soldering them, they break apart. It's a nightmare. So I do 3 joined together on my Reflow Master Pro, and it's just manageable enough, the bow, that when I'm soldering, if I kind of try to, because this bow will actually flex the PCB. So anyway, my plan is to do two lots of two, because 2 lots of 2 really doesn't bow. Cut off the joiner parts. Well, I don't want to cut off because then I've got to solder them individually and they're not lined up. The whole point is this allows me to line them up. So it's not about cutting them off. I don't want to do, so this was 12. I need 16. So I'm going to do 2 lots of 8. Now, what I need to check though, is this 5.08? It is. And they're actually 5mm. Anyway, it doesn't matter. So I got rid of 4. So I need to move these. 4 times 5.08. 4, or is it 2 times? 2 on each side. Yep, 2 on each side. That's not the middle. 2, 3, 4, 2, 7, 4. Oh, because they went in the middle. Anyway, interesting. 5.08. 5/2, 2.54. And that should be, so 0.2. These all have to move over. Oop. Negative 0.2. Okay. Fine. What am I doing? I don't even use these. I don't even need them. Whatever. Don't care. Anyway, so there'll be 2 of these. So the board's got to change size quite a bit. I can't have them next to each other. So it needs to be long. I guess I could do like one that way and then one the other way. Didn't get why it isn't more like CAD software where you define constraints, but I guess somehow this is what everyone thinks is nice. Yeah, I don't know how it would work with constraints. I mean, that anyway. Yep. So it's all of these have to go. I don't want to use smaller screw terminals because they are they're janky. They yeah. Guess I could always make, I can't really do side by side. They won't fit. I have to make the board considerably longer. So yeah, the thought was that I have wires going out the sides. So these ones go out up and these ones come out this way. Not sure. Yeah, I don't have pluggable. I want to use what I've got here. I've got stacks of 3.81. Stacks and stacks, but I just always found them to be pretty, yeah, these type are just pretty crappy. You know, the metal things inside the plastic, they're loose. The pluggable ones I'm sure are nice, but I don't have. I literally have to make all this be out here. And then I'll have all the empty spot in the middle. Rising clamp style ones. Do you have a link to the ones you use, Quindo? I've seen. I mean, the ones you use on your stuff look really nice. Like I have to admit. And the connectors you put on for your spade terminal stuff and everything else are nice. I've never looked at stuff like that for my Reflowmaster Pro because they're too expensive. Comparatively. And okay, so which one? Do you have at least one code from LCSC? Oh, hang outside. Pluggable screw terminal. Oh, can't spell. Connectors, you connect spades. Terminal block accessories, specialized. Oh my god, look at all their so LCC have changed all their categories and names and everything else now. For those that aren't aware, if you look at the view all, everything's been recategorized. So now they used to have just 2 category groups, like there'd be like connectors, and then inside connectors would be mail headers, right? Now there's connectors in connects, and then inside that you've got like AC power or memory, and then inside that you've got other ones. But I don't know what they were thinking, but if you look at, so under connectors, they've got terminal blocks, yeah? But they've also got terminal blocks under something else. Hang on, terminal. Can't spell. No. So they've got terminal blocks here, right? And they've got terminal junction systems, terminal adapters, and then under here, oh, is that the same one? But that's not under. Right, they've got that's what it was. They've got terminals, and then they've got terminal blocks. Like, what's the difference? Screw terminal. Like, what's the difference between a screw terminal and a. Anyway, whatever. I have mine custom made in bulk because I use colors and also like Phillips head screws. The ones after I sonic cleaned the PCBs, the blue tarnished, as in discolored. Is that what you meant by tarnished? What are you ultrasonically cleaning your boards with? Please don't say IPA. That's a random example. Yeah, that's okay. Just it doesn't have to be your exact ones. I'm just curious. Something like. Right, but that needs the other side too, right? So that needs that matching side. And they never link, they never show you what the mating pair is on this, which is the problem. I mean, all of mine screw terminals go through ultrasonic cleaning, and they don't change color at all. But you shouldn't be using IPA if you are using that, because that's highly flammable. It's not designed for that. I know plenty of people use it, but it's not designed for it. You should be using just a saponifier. So I had for, I don't know, what year is it? 2026. For the last 5 years or 6 years, I've been using a saponifier in mine, which is just, it's not non-chemical. Like it's just soap, right? And 3 weeks ago, I cracked the shits. I needed to buy more, and it wasn't in stock. There was a delay to get them, and I cracked the shits, and I thought, why am I doing this? I use water-based flux. And so I got rid of, I use distilled water now. I just ultrasonically clean all my boards in distilled water now, and they look fantastic. And I don't have to, because the saponifier, when you take it out, you got to rinse it off. And when you rinse it, it turns into bubbles. It's like any soap, right? And so just my sink fills with bubbles. Like it's a real pain to, and you have to clean all the saponifier off. You can't leave it on. It's just a pain. So now for the last week and a bit, I've been cleaning all my stuff with distilled water, and magic. It's great. I love it. I take it out of the ultrasonic cleaner, just do a quick rinse, put it in the dryer. Done. It's just awesome. And I'm just kicking myself that I didn't do this years ago. But it only works if you're using a water-based flux. If you're using a non-water-based flux, well, saponifier won't work either on a non-water-based flux. I tried brake cleaner from a spray can. Brake cleaner from a spray can in an ultrasonic cleaner to clean your electronics. Really? Dave, there's a whole world of products designed specifically for ultrasonic cleaners for electronics, and none of them are automotive. Yeah. But each to their own. Yeah. So you need to find a cleaning solution that matches whatever the flux you're using if you want to clean the flux. Or straight onto the PCB. Didn't you say ultrasonically cleaning before? I had to remove blue connectors after I sonic cleaned the PCBs. Oh, are you saying, so you're not ultrasonic cleaning, you're now just using brake cleaner? Ugh. You can search the terminal block headers, plugs, and sockets, and then for the plug of the socket side. Yeah, sorry, I got distracted. I'm just curious to know what a matching socket would be. But I want to see, do they have 4? I'm just guessing with the product name. So they do a 4-pin, okay. Yeah, I need to find out from there'll be a matching one of these with different letters for the other side. Yep. So do they do bigger than 4-pin? Bet you they don't do 8. Some of the good brand ones, oh, maybe they do. Okay. Okay, now I need to find the matching one for this. Okay, so hardest pins and sockets. So Kangex. Kang next. Kang next. Kang next. 3.81 or either of those. And what was it? 8. Apply. Is that the socket? I don't know what a socket looks like. There's the wire. That looks like the socket, right? That the thing connects into. Discon has a good online catalog. Okay, I can look at. I think that's the socket, through-hole socket. Yeah, okay. But I need a right angle one. Yeah, I need a right angle. Is that a right angle? No. They're the only ones I've got listed here. Okay, I can do some research, but at the end of the day, I've already got these other ones here. I don't really need pluggable. There's no advantage on pluggable other than if I could find if they were smaller pitch and more reliable. Oh, through-hole right angle. Sorry. I had the wrong one selected, it looks like. Okay, here, through-hole right angle. See, I look at that and I think, how is that going to be stable? They're just wires going in and through in the plastic. Like, how's that not going to wobble and whatever? Okay. Well, this is an option. How's your SQUiXL project going? What do you mean by going? Am I selling many? No. Have I sold many? No. I've been chipping away at new firmware. I rewrote my own graphics library specifically for SQUiXL and stuff. But yeah, it's it's dusty. I don't know if it's got any battery.
Hello.
Hello. So this is unreleased firmware. I don't know if this will find internet because it did. This is unreleased firmware that has built-in Wi-Fi manager that I've been working on. Ooh. Oh, wrapping. How funny. Okay, text wrapping. With selection and keyboard and whatever. So if you're joining without using your phone. Anyway, it's using a new graphics library and stuff. I've been working on. I've got bugs and stuff still to fix, but I've not released this because Espressive screwed me. No, so this is stuck on Arduino Core 3.13 because Espressive made some changes in IDF for their RGB peripheral, which has trickled into the Arduino core now, and they've depreciated some settings that I use, and they haven't put in alternate settings instead. And they've got other things that I have to move to instead that prevent me from syncing the screen correctly because of the flash contention. So what they've done is improve their RGB peripheral massively to work with the P4, which uses a separate bus for flash. So and it uses 16-lane PSRAM instead of the octal that I'm using. So the PSRAM's way faster, which means they can refresh the screen faster. So they've removed the things that I hook into to allow me to keep the screen not flickering and juddering when I'm accessing flash at the same time. And so it means that this is stuck in an old version of Arduino. Every attempt I've ever done to move it has failed. It just becomes glitchy and I can't control it. It's out of my control. I can't fix it. So, which kind of bummed me out a bit. But I have been working on some firmware stuff for it. But at the end of the day, I've not sold and not selling enough units, and had pretty much no contributions from community on it, except for Matt and someone else, can't remember. I mean, yeah. So, you know, it's one of those things where I was hoping there'd be more community people contributing stuff to it, but it hasn't happened. So, yeah. And look, it's an expensive device, unfortunately. So, yeah, I wish I could make them cheaper, but I can't. Well, these are all documented changes, but they're changes that have no. Yeah, I can't use those changes with this. There's no way on the S3 to separate flash and PSRAM, put them on separate SPI buses. So nothing I can do. Johnny has a pink one. I mean, I've sold 60, I think. 60 or 70 I've sold, which obviously is, you know, it's not a lot. Not for what I spent just in time in designing it, and then, you know, time I spent on firmware and stuff. That's okay. It is what it is. I was, you know, it's not the only project that I've ever spent time on that hasn't really gone anywhere. It happens. That's okay. I enjoyed working on it, and, you know, and I still tinker with it.
Chat has disconnected.
And he's back. I still tinker. Ultimately, right now, all my time is.
Geek says greetings, mortals.
Hello, QUIXL Geek. How are you? Yeah, I still learn. It was great. There was quite a few firsts in there, and the design of that. But like all my time at the moment really is taken up with client work. I have a lot of things, a lot of, like, let's say, personal, like, unexpected maker stuff in various stages of all over the place that I just can't really find any solid chunks of time to work on anything. And it just is what it is. I have to, you know, I just tell myself, you know, be disappointed and get over it, and get back to doing new client work. So, yeah. If it wasn't for my client work, I would have been out of business 6 months ago. So, like, I would have shut down. So, yeah. Like last week, I was here one day in the week. Most weeks I'm only here a couple of days, and it's generally manufacturing, filling orders, writing emails. Like, you know what I mean? Like, it's just very little time to do anything else. But yeah, you got to do what you got to do. QUIXL Geek is alive. Well, I'm glad to hear, because you're typing. That would be quite a feat to be typing if you weren't. But good to hear. Just alive is not much of a aspiration, but look, I'm enjoying the client work as well, which, you know, if I enjoyed the client work less, I'd be more inclined to do my own stuff instead. But my own stuff is not revenue generating, really, beyond my staple products. So, yeah. What do you mean by client work? I been designing and manufacturing and so much coding for client projects, for, you know, products for clients. Things, I mean, I've been showing testing jigs and stuff. I've been doing a few things that I've shown on stream on from a testing point of view, but I've not shown any real product. I'm not allowed to show any product stuff at the moment. But yeah, actually making, like, designing electronics, testing, and firmware for products for clients. So, yeah, it's basically what I do for myself, but for someone else. But, you know, I'm only taking on design work for stuff that I'm manufacturing. Like, if they want to manufacture it somewhere else, then they can get someone else to design it as well. And I'm not manufacturing stuff for people that I didn't design. Like, it's a all or nothing kind of thing. So I've been on site a lot. My biggest client, they're in Patron, which is about, on a good day, 25 minutes away from me, and on a bad traffic day, an hour and a half away from me. And no, it's not consultancy. Like it's I'm doing it all I've taken over all of their design, manufacturing, testing, and coding for them. They were manufacturing themselves internally. They had, firmware developer here and a hardware designer here and whatever else. So I generally would consider consultancy is where you go in and someone pays you for your advice. You review stuff and help them with whatever. I am their design, manufacturing, and firmware department now. So it's a bit more than just consultancy. But it's fun. Like it's cool stuff I'm working on. I've probably, on some of the things I've done my best work on. And then on some of the things I'm avoiding doing my best work on. As I said, like the tester for that large board, the USB hub board. I could spend weeks and designing the most crazy out there testing jig for it, but at the end of the day, it doesn't need it. So, I'll end up making something that's just pretty simple and effective and uninspiring, but it'll work. It'll do its job, right? If you're designing software, hardware, and manufacturing, what is everyone else doing? Well, there's only a few people in the company now. Like I've taken on stacks of roles. Like I'm doing, they do a lot of most of their mechanical design work, like their cases and fixtures and all sorts of stuff, is done externally through a really cool design company, right? But I jump into the 3D side and the CNC side as well. Like I was again set up all the tools and stuff to CNC all the test jigging stuff, and I designed them a whole bunch of testers for something. Like I don't just get to work on the products that they need, but I get to come up with ideas on how to test those products as well. So I made a tester that kind of works like one of their products. So they've got a product that another product attaches to, and that other product can only be used when this main product is being used. How do I put it? When it's when it's being used properly. This has a purpose, and this can only be talked to from this when this has a live purpose. I don't know this. So I designed this that is completely different, that doesn't need any purpose, that can test this. I can't. Anyway, and so I designed some really cool front cases for it. It's a 3D printed front case for this thing that gets attached to it, and it's got a screen and buttons and stuff. So and the screen shows real time what this thing is doing, so we can test it. So these are all sitting on this big robotic thing. This machine that simulates movement, and all these little devices with screens are counting and showing and testing these things. Like it's just I'm getting to work on some really cool stuff and come up with some really cool ideas. So so you may have accidentally fell into the dream job. Kind of. It's so. Let me just go back and read what everyone else is saying. My business cost me £1,200 a year and there's no sales since 2019. It has me about 10 grand. I keep going, but I have to hold down a day job to funds coming in. It's the same thing, right? I'd rather be doing this and making my own stuff. But it's a very tough, bad market at the moment, and it's just I'm not generating enough at the moment to stay in business, right? And so I'm contracting my services out, not just me, but my facility, right? Like, when I manufacture these things for clients, it happens here. So, but what I'm doing for this client is like I would do for myself. So, what I don't do any contract work for clients that have clients, right? So I don't work for any agencies, or I don't do any client work for companies that make products for other people, right? So everyone I'm working with, it's their own product that they're doing, and that's different. That's where I draw the line, because so the stuff that I've been doing for this main client are exactly the same things I'd be doing for myself. Like I'm using, a lot of the same hardware, like as in ESP32 S3s. I'm also working with a whole bunch of stuff I normally wouldn't work with, STM32, MSP430s, whatever. This stuff leverages all of my knowledge base in terms of designing, manufacturing, testing, all that type of stuff. And it's like, so I'm making a product to be sold, not making a product for someone else to sell to someone else who then sells, you know what I mean? So I don't have any of that. There's no meetings. There's no having to hold the hands of a client through a design brief. There's no the client coming back going, oh, such and such said blah, 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 so we want to change. None of those type of things, because it's like I am doing the work, like, you know what I mean? Like it's the client's product. Anyway, blah, 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 blah. The point is, it's very similar to what I'd be doing for myself. Yep, no meetings. I mean, we get sidetracked in discussions sometimes, sure, but who doesn't? But there's no meetings. There's just discussions of things we need, or how are we going to do this? How are we going to do that? And there's some really complex parts of the projects coming up. That are going to be really challenging for me. So much so that I might get him to handball them to someone else. But it's good. It's fun. Like they're all, yeah. It's been flexing my abilities and my knowledge. I've been learning a lot. But it's also completely in my wheelhouse, right? So it's great. Hey, Richard. Hello. Did not see you there. I'll catch you later, David Essa. I missed it. Sorry. So it's been good, but it's a lot of my time. As I said, my manufacturing here takes priority. If I got orders, reseller orders, or whatever comes in, that always takes priority, and his client's really flexible with that. It's great. And then, the rest of the time, there seems to be an endless amount of stuff for me to do. And, yeah, there's only me. So, sometimes I'm either, doing 6 things at once for him. And, sometimes he's chasing me on things. But, we're getting there. It's good. It's good. And that's what these new tester boards are for. So these tester boards should have been designed at the time that we were redesigning the products, but there was no time at that stage because we needed to validate the products as functional in the ecosystem of stuff. And so now we're circling back to what's the best way to test them, other than me testing them individually, which I have been doing. So yeah. Just takes time. Making testers takes time. A lot of redesign. Like that tester board that I showed, like the one that does those dual devices testing, that was like a 5th revision of the test jig. The first one I made, and it worked flawlessly first time, but it was the 5th design because I just had to keep iterating in my head best way to test it. If I would have gone with the first version that I was thinking of, it would have been twice as many components, 10 times more wires, and turns out that I wouldn't have needed half of them, or I could have worked around half of them. So I'm glad I kept revising it, but that takes time. You know, you don't revise it 5 times in one day. It's got to simmer. It's got to, you know what I mean? So, yep. The problem with me now is I have proven to myself that I can test multiple boards concurrently on a single Pi. So all of my test jigs, my current test jigs, are still, oh, Jesus. Are still these single per, right? So that's for a Feather S3 in there right now, right? They're all a single board tester per Pi. And now I've got it stuck in my head that I want to make a 1 Pi that can test 4 boards. Doesn't matter which board. So it'll be a 1 Pi with 4 inserted adapters, whichever adapters. So it could be this is a Pro S3, it could be a Pro S3, a Feather S3, and then 2 tiny S3s, right? Whatever. 4 different unique adapters in there, and I load up the boards and hit the button, or load up however many boards I want, hit the button, and it detects each one and just concurrently flashes and tests them. And at the end, I've got 4 or however many boards I put in tested. And I've got that in my head now, because what do I test? On my own boards, I test everything. Well, I test obviously the power rails that they bring up. I test battery charging. I test all the IOs to make sure that there's all electrical continuity between them all. I test the radio and the RF performance. Well, that's interesting, and I've just changed that recently. I came up with a brilliant bloody idea, again, because of something that I found when I was doing the client work on the IDF side. So I'll explain what I did in a minute, and I've halved my testing time for every board that I test. Unfortunately, I only did this about 2 months ago, and I wish I would have halved my testing time for the last 5 years. Yeah, no, and I do finish projects. I finish for them and I finish for me. I do. I've never been unable to finish projects, but I've got way too many ideas and never enough time for the projects I want to do. So anyway, I test USB, obviously, because I use the USB connector. So I test as much as I can on the board. So for my new boards that are using the fuel gauge gets tested. So it used to be between, and this is a lot to do with CircuitPython. So I ship most of my boards. I ship all of my boards with CircuitPython on it, other than my tiny Picos that ship with MicroPython on it. CircuitPython is slow to flash and slow to mount, because it mounts a USB, like a mass storage device. So it's got to enumerate. So it's got to do, right? So it's, so I used to be able to test a tiny Pico in about 48 seconds, and a tiny S3 in about 52 seconds, and a Pro S3 or Feather S3, because they've got twice as much flash, so they take twice as long for CircuitPython to flash and whatever, in about 78 seconds, right? Which is still, it's under a minute per board for testing. And if I've got 3 test jigs in front of me, I can test 3 boards concurrently, right? But now I can test the same Feather S3 that was 78 seconds in 38 seconds. So a lot of it, the slowdown was because I made the RF testing way more robust. When I had that drama, when I first shipped my S3 boards, those of you will remember, when I first shipped my S3 boards, there was an issue with the S3 chip that was undocumented, and I found out after I shipped, and I had a situation where I had a whole bunch of boards, and in my office, let's say 80% of them passed on the test jig, the RF testing, but out in the wild, 40% of them didn't work for some people, and the other ones worked, right? and it was an intermittent problem, and it had to be fixed with a change in the RF layout, which was fine, but I needed a complete different way of testing to see the issue. So I changed all of my testing to be, do you remember that? That cost me a fortune. Catch you later, Dave. Have a good sleep. So that particular disaster cost me about $7,000 or $8,000 of having to get people's, like the ones I could get back, like from resellers, I had to pay to get them back, and then I had to fix the ones I could. And the ones I couldn't, I had to obviously remake, and then I had to reship. So that was a very expensive thing that I had a nice discussion with Espressive about, which they subsequently updated their docs, updated their data sheet to mention it. There's an oscillation problem on the S3 at certain channel levels, and that you need to put not only a matching network on there, but you need to suppress the second and beyond harmonics on the chip. And that was undocumented. So if someone was using channel 9, it would work great. If someone tried using 6, it might work sometimes, some not times. And if they happen to have channel 1 on their board, on their network, and they were using USB at the time, the harmonic oscillation would prevent the RF from working. So at that point in time, I was testing the middle of every one of my boards. So the middle frequency, right? And so I was testing generally channel 7 or channel 9. And if that passed, I'd go, right, my RF's working, right? If I was getting the results I was expecting, I wasn't doing a Wi-Fi scan. I was testing the RF, I was connecting with it, but just in the center. But the issue was at the extremes, right? Channel 11, channel 1. And so when I fixed all that stuff and moved to the Johansson network on my boards, Johansson antenna and that 5-part complex matching network, I implemented at that point a testing jig downstairs, a testing harness downstairs, where I would test channel 1, channel 6, and channel 10. And so each board had to connect, not just look for, it had to connect. So there was APs sitting downstairs. It would connect to channel 1 and check the connection time, and then it would check channel 6 and it'll check channel 10. And if any of those failed, the board would get put aside. And then, so that took 3 lots of connections, 3 times as long. And then when I added the D series, I had external and internal I had to test, which means I doubled the testing network downstairs. So there was 2 lots of channel 1, 2 lots of channel 6, and 2 lots of channel 10. And I would test the onboard to one set and the external to the other set, because I couldn't test them all to the same because they couldn't do that many concurrent connections, right? If I was testing 3 boards and 2 of them hit the same channel at the same time with the same thing, then one of them could fail. And that's a false negative, right? It failed because the device was in the middle of connecting something else. And so, like, if I reran it, it was fine. So I had to split it off into 2 halves. And that doubled the RF testing time again, which got me up to 78 seconds. So the reason you don't test, the reason you can't just look at the RSSI, like have my board look at the APs and go, what's the RSSI, is that's testing the receive of the board. It's testing, and pretty much you can remove the antenna off a board and it'll still receive signal, right? You'd have to have a really bad design for it not to be able to receive. So you can't use that as a measurement. What you need to test is the transmission, okay? When you have a bad RF layout, or if you had a problem with your RF layout, it's the transmission that reflects and bounces back. It's the transmission that gets deteriorated, and if it's a bad reflection, damage the chip. So if it can't connect to the Wi-Fi access point, then there's a problem with the transmission, not a problem with the reception, right? So what you can't do is get an RSSI from the AP. The AP can't tell you what my transmission RSSI is on my board, right? And even if I connect to an AP, it can't tell me what my RSSI is. But unless you're using some type of ad hoc sniffing, but you can't do it on a regular AP. You need to anyway. So one of the things that I do, one of the products you use with this client network is we jump into ESP now. So there's a network of devices being used for a session of something, right? And there's a main device, and that main device configures all the other devices initially through ESP now and tells all these devices how to connect to it, right? So by ESP now, which is, just broadcast out. It's not, it's UDP, it's not TCP, it's not guaranteed delivery, and you can just broadcast, right? You don't have to have a Wi-Fi connection to do it. So it broadcasts out, it does all this comms to tell all the devices how to connect to it. Then they all shut down their ESP now and connect, right? That's how we build a network. It's like it's not quite a mesh network, but it's a completely ad hoc Wi-Fi network for this thing. And so in my digging of that, I worked out that we could, so we wanted to be able to test the transmission connection speed to the main device from all these other devices. And we could do that via Wi-Fi when this main device was an AP through this promiscuous mode. And the promiscuous mode is like sniffing packets. And when you sniff them, it'll tell you what the RSSI of that packet was, which is effectively the RSSI of the transmission. It gives us a reverse transmission power value, right? Which is great. But I can't do that for my test jigs because I can't be a promiscuous thing, right? I need the test jig. I need the device on the test jig to know what its transmission is. I don't need that device. That device knowing what the transmission is doesn't help me, right? I need this device to know what its transmission is, to know if it's a pass or fail. So I found this weird thing in ESP now that lets me, if you enable it, you can capture the transmission. You can capture the RSSI of the packets back and forwards. So what I do now is I have those things. Sorry, this is all really complicated. Have I put everyone to sleep? So what I do now is all those devices downstairs aren't running APs anymore. They're all running, there's 3 of them, and they run ESP now on 3 different channels. And all they're doing, they're just constantly sitting there with ESP now, right? And on my test jig, my device, when it's being tested, it doesn't have to join anything, right? It just starts talking to the ESP now network, Johnny, on those channels, and that the devices over there capture the data from them, and then when they send their packet back to these devices, they include the data of the transmission to them, and so the device gets back its receive RSSI from that and the receive RSSI that got from it. And it does it in sub 30 milliseconds per channel. So now when I'm testing, I do it twice. I do it once for onboard, then I switch the RF, then I do it once for the external. So every board I test, I have to manually plug an antenna onto. That's fine. And I test it, and the whole 3 of each channels testing now, including retries if it needs, whole testing takes less than 1 second. So now all my testers, that whole slow process of Wi-Fi goes all the way down, and I get results back that look like, I might actually have something open that I can show you. There we go. So check this out. So this was testing a Feather S3. This is testing a Feather S3. And you can see here, it does a antenna test. Okay, so there was two attempts. And the reason for this is I've got multiple boards hitting the same things at the same time, right? But each one shows me how many attempts, at what channel, how long it took, and the RSSI of the server and the RSSI of the device being tested. Bang. So that's less than a second, and that's including the attempts. Do I have one that's got? Okay, that was one attempt. That was 4 attempts. That was a fail on that one. So Wi-Fi fail, right? And I probably ran it. That was probably the same board I ran again. It was fine. Here we go. 1 attempt, 1, 2, 1. Like, it's just super fast now. And so that's all the I/O being tested. Right, and test the RAM size, flash size, battery voltage. That's slightly out. It checks that the 5-volt sense pin works. So all that stuff. And yeah, amazing. Best thing I ever did. Took me about a day to get it working. So now what I can do to get rid of these retry attempts, I just need to add more. I need to do a set for onboard and a set for external. So when like I was testing 3 at a time. So I've got a test sheet. Well, you can't really see it here. The one I just picked up here, right? And then this one over here, right? I was testing three boards concurrently, and each one were, very quickly switching between the RF, hitting the same 3 things at the same time. So I wanted to run them for quite a while to make sure that it was 100% reliable. And now and they're tiny picos. So it's just a tiny pico, 3 tiny picos sitting down there. They're running MicroPython. They're doing ESP now in MicroPython to do all this, because it's just easy, right? And I just need to add another 3. And I can add as many as I want. Now that it's so quick, right? So before it used to be 4 seconds per channel per antenna, right? So 6 times 4 seconds it used to take to do the Wi-Fi check, because that's how long it takes to connect and get an IP. It's DHCP and all that stuff, right? So now I could effectively put 10 of them per thing and I could check every channel in 0.01 of a millisecond, 0.01 of a second. I could check every channel, right? So yeah, it's great. Really good. One of the best quality of life improvement things I've done in a long time. But if I could get 3 testers, 3 or 4 DUTs on one Pi, I won't have to have 3 lots of Pis with cables everywhere, all in front of me, all the time. I could just have one. Whew, that'd be awesome. But I don't know if it's worth my while making the changes. Okay. 3 hours. I've done lots of talking. I didn't do any changes to the PCB, but oh well. I'm going to put this away before I lose it. There you go. My ability to stream every week is going to be limited for the time being, just with this client stuff. Yeah, if it's a client day, it's a client day, and that's just what it is. So I hope you'll all understand. Yeah. Did that explain everything to you? Oh, Quixotic Geek actually left anyway. Right, well, I was explaining it all. All good. Have a good sleep, although you're already gone. So I had that screen was on top of my chat window, so I couldn't see it. Okay, folks, I'm going to go. Have a nice week, everyone. Matt, I'll catch up with you on the weekend. Matt and I are catching up. Mac's coming down to Melbourne. Woo! So, Yep. We're going to talk crap. It's going to be awesome. Yeah, have a great week. Thanks all for joining, and hopefully I'll see you next week. And hopefully I'll start having some project stuff to do at some stage. I will at some stage. I just don't know when. Okay. Bye, everyone. Take care.